Well, how's it going, everybody, and welcome back. Today should be a pretty fun video. We're going to go over to Hot Rod J's and fix the head that's for this 4-liter on this 2000 Jeep Wrangler TJ. Got the head over here on the bench. Just have to load this up into the car. Weighs like 80 pounds. Then I've got all the new stuff for it. So once we get over to J's, we'll see what it takes. Also, I've got a bunch of rust repair, like frame rust repair stuff for the 96 TJ that's sitting outside. So I got those from Max Speeding Rods, and we'll take a look at those things later on. But let's load up all of these parts here, head over to Jay's, and see what's up with this head. All right, got the new valve here, or one of them, and the other one is inside of there. They're sold in a pack of 2. New valve stem seals, might as well throw those on. Old spring keepers, all that stuff, and then here is the head. So if you missed the old video, a nut actually got stuck inside of here and wedged the valve open, and believe it or not, that is what was stuck inside of there. So I'm taking this over to show it to Jay because he wanted to see it, but it was wedged right in there holding the valve open. So that's pretty crazy. But other than that, everything looks pretty good in here. I think we'll be okay. Whatever, we're gonna load this stuff up. Well, for everybody living down south in these wonderful states that's nice and sunny and warm, it's -10 right now, 30-mile-an-hour winds. It's freezing cold, so enjoy your sunshine. I'm jealous. Well, alrighty, folks, we're over here at Hot Rod J's. He's in the house. He'll be out here in a little bit. One thing to keep in mind, Jay has been on the channel before. If you've watched any of the early videos where we were building the engine for my D150, we did it here in his shop, but Jay isn't really like a YouTube camera kind of guy, whatever. Sometimes he'll do it when I ask him to, but other than that, he just likes to get the job done. So I don't know if I really want to be all up in his face with the camera or not. Some people are into it, some people aren't. Jay's not really. So I'll film what I can film, and you'll get an idea of what's going on with the valve job. But other than that, we're just going to try to get the job done, and I'll take you along where I can without, being a nuisance with the camera. As I said, some people like it, some people don't. All right, so here we are. Jay's got everything all set up. I'm going to let him take it since he's the expert here.
This pilot goes down in the guide and fits tight in the guide. This is what's called a dead pilot. And all of our tooling, we've got all of our 3 different tools here that we're going to be using. All these tools, they slide down on the pilot, and that gets the concentricity of whatever we're cutting will be concentric to the guide, because everything on a valve job is central to the guide. So for the process, you put the pilot in. So here's what the pilots look like. The top part is ground at a specific diameter to fit the ball driver. The bottom part is actually tapered, and that wedges into the guide. So that's what the pilot looks like. That pilot, that guide that the pilot's going into has to be squared up to the machine. This is our guide, our pilot that's in the guide. We have to square up the head to match the spindle and then also get it central. So this fixture actually, it's called a rollover fixture. It rocks this way and it rolls this way so that we can adjust, we can square this up to the spindle perfectly. And we've already done that. Use indicators. We get it square first, so the 2 are square, and then we put it central by just using our table movements to get central. So that's already been done. We have to put a seat in this head. So a seat insert. So this is the seat insert here. This seat is intended for a 2-inch pocket, but the actual seat is 0.6 of an inch bigger than a 2-inch cut. So we're going to need to bore a counter bore in here that's 2 inches in diameter. So what we're going to do is we're going to rough it in with this tool, and then we're going to finish it with this tool. Then we'll take the head off and we will install the seat. That seat will get driven into the head. Then we'll put it back on the machine. We'll square the guide and the pilot back up to the machine, get everything central, right back like we are now. Then we'll use this tool, and this is actually what you'd call a form tool. This has, it's probably gonna be really hard to see this. So if you turn that just right, you can see that there's 3 different angles cut into that carbide insert. And that is this will give us a 3-angle valve job. This will be a top cut, a seat cut, and then a throat cut. And all that's into that one form tool. So once the new seat is installed, it's gonna have a square edge. There's no seat to it, no seat angle, no nothing. It's just gonna be a square edge. So then this tool will go in and it's gonna come down and it will form that valve job in the inside of this seat. And we'll show that more when we get to it. But, so that's the tools that we're gonna use, these 3 tools to do this. Now, I will show you, these are called bounce springs. They go on here. And then your tool goes in here. So we have to cut that seat to a specific depth. So what you do is you come down till the cutter touches the head, and then the stop on your machine, we've set that for the thickness of this seat. So that's an important thing to know too. If that seat were sunk way too low, by the time we cut the seat, the valve job would be too deep. Because it's a non-adjustable valve train, it's more critical that that valve job cut is cut at the right depth. So what we have is we have a tool here. This tool goes in, and this pointer right here touches the middle portion, the 45 degree of the valve job. That pointer touches that. And then what we do is we rock this till we find the fulcrum point. And you can see we've zeroed out the gauge. We've done that now with this seat cut so that when we do the new seat, we know that the new valve job is at the same height as the old one. Because if we don't, the deeper we cut this seat, the deeper this tip height goes down. The way it's sitting here, it's going to go down. And that tip geometry is important. The tip of that valve, the height of it is important. So this will allow us to cut this new seat valve job the same as the one that's existing. So we'll try to show that a little better. So we've got all of our gauges set up. For reference, this tool here, I'm just using it to plow out all that material. This is set 40 thousandths of an inch too small. And then we will do our finish cut with this. It'll be a light cut. It'll be a lot easier to handle and get that precision because this needs to be precise. So that's the tools we're going to use, and I think we're ready to start cutting.
So the humming that you're hearing is the 3-phase converter that's up in the ceiling. So any hum that you hear, you can't do anything about it because it changes the regular 220 phase from outside to one that these machines use. So that's what the humming is.
So you would call this like a seat pocket or counterbore pocket. And we've pre-adjusted that stop. If you do this all day and you do a lot of seats and you watch that tool over and over, you talk about making you go kind of crazy watching it. Especially when we get to the single point cutter, the single blade cutter. Let me blow that out a little bit. So these are the seats that we're using. This is SBI. They're a real popular brand. Qualicast. There's a couple popular ones, but a lot of them use a similar system. And in the part number, SB 2000-1. So what this refers to is this seat is meant for a 2-inch counterbore. But when you mic this seat, it's actually 6 thousandths bigger, 5.5 to 6 thousandths bigger. That provides, so when you cut it at a 2-inch, a perfect 2-inch, that would give you 6 thousandths press, which is adequate for this application. As a side note, this -1, that you could have a -1, 2, 3, 4, 5, 6, 7, 9. There's a ton of different final numbers, and that refers to the height of the seat, the inside diameter of the seat, all kinds of other things. But this is a relatively shallow seat. So with a relatively shallow seat, you would see something like that, 5-6 thousandths press. That's common. So what we're getting at is it's important that that pocket is 2-inch. It can't be 2-inch, oh well, we're 4 thousandths over. No, then you'd have 2 thousandths press. That's not going to live. So we have a tool, this. It's just an inside, I think you technically call it like an inside dial caliper. What we will do is we will set this to 2-inch. Keep my eyes on here. Okay, that's set to 2-inch. All right, so we've zeroed this at our 2-inch. So our goal is to get that pocket to 2-inch. Now this should be approximately, we're gonna pull the pilot. This should be approximately 40 thousandths of an inch tight. That's roughly what I set that tool for to rough it in. Okay, so it's 42 thousandths tighter-ish. Somewhere in there. I can't get your angle, but 43 maybe. So we're about 40 tight, which is what we were shooting for. So what we're going to do now is we got to get the pilot back in. So now we go to this guy here. This was the one I was telling you, right? Like this will just screw with your mind watching this all day. But this is just a 90-degree cutter. All this is to do is to take that counter bore, and now we're going to finish it out with this. So we will get this set, and what I'm doing here is I'm just creeping this out till I just get a drag on it. So the 40 thousandths that it's tight, this pocket is currently too small. We got to get it 43, 44 thousandths bigger. Well, that's only 20 to 22 thousandths aside of actual material removal. So what we're going to do is we're going to take this. Actually, I lied. Let's go back. I'll set it a little bit too small so it fits down in the bore, and let's set our stop for our bottom. Okay, so I intentionally set that cutter too small so that it sits on the floor. Got that on the floor. Let's get our bounce spring in there. Okay, so it's off the floor. I want to find the point where we're just a hair above it. Okay, right there is just a couple thousandths above the floor. So what we'll do on my last final pass, we will creep that back down and we'll clean up that floor and be done. So we're not really changing. With this first cutter, I set the depth. I will go and just kiss that floor to clean it up at the very end with the last final cut with this. So now I will go back and get this to the point where I'm just skimming the outside. Okay, that's just scratching the cut. I'm going to come in here on this fixture here. Okay, I don't know if you can see it, but we're at about 80 thousandths on that dial indicator. We know that we need to cut about 40 thousandths more, 44, whatever it was, 44 more. So I know that I got to move this cutter about 20 thousandths more to get that 40-ish thousandths in diameter. So what I'm going to actually do is I'm going to do half that. I'm going to set, I put it in, I was scratching the edge. I'm going to take this and I'm going to go 10 thousandths bigger. Okay, so this is just a reference. This doesn't mean I'm going to cut a something in 80 thousandths pocket. This is purely just for reference. So I was at 80. We're going to extend that out a little, and I want to go to 90 to get that. There's 83, 87. And I don't have to be like perfectly 90 for this one. $89. All right, so this should be, there we go, 90 and a feather. So I will snug this down here. Just for how it works, this cutter is on this rail, and there's a set screw there that pulls this rail in or out compared to the main body. So that's how you adjust the diameter. Okay, so 90 was our target. Okay, 90. And now this is still going to be shy. This isn't going to be a finish cut. And again, we have set that stop so that we won't go too far. All right, so we've got the seat pocket cut to final size. What we have to do now is we have to press the seat insert into the head. So this is just a simple split pilot. It's not a precision pilot. It's not like the ones I showed you. This goes in the guide, okay? And just for reference, that has the same top diameter as our other tooling, and this driver has the same diameter machined into it. So got a bunch of different various discs. You find the disc that fits the pilot, or the, not the pilot. Find the disc that fits the seat, and then we're gonna take the head off, and then we will literally just take that. Can't do it because that's in the way, but that'll sit down in there and let's press it in. But it's important to note that I've taken, we did it off camera, but I've taken and just done a light, I just broke the edge, the outside edge of this seat pocket cut. You don't want to go in with a machine and put like a, a radius on it or a chamfer or anything like that. But you do want to just break that edge. It'll help from getting it cocked as you start it. But more importantly, it'll help keep you from getting a curl, a chip. Any piece of debris under there is not good. So you break the edge with that.
And the seat has a chamfer on it.
Yes, and the seat also has a chamfer on it. Now, I kind of explained a little bit of the part numbering process a little bit on that, but some of the seats for aluminum heads, they're specifically designed where they actually have a radius on here. This one, I don't know if you can pick it up on the camera, but this one is a literal flat chamfer. There are the seats for aluminum heads will have a literal radius in it so that they're less likely to gouge up, because that aluminum is softer. It's more likely to burr something up and get caught under it. So there is that, and that's all ironed out in the part numbers of the seat and what you order and all that. But for this application, simple little chamfer on the seat, deburr there, lube it up and press it in. Okay, we got our pilot in. We're gonna take...
This is the technical part. A hammer.
Yeah. Now it is important. You would think that this would be common knowledge, but obviously the chamfer needs to go down.
Yep.
And this will kind of self-square itself, but you still need to get the seat, right? Because you can you can put them in cockeyed. Like without this driver, you really got to be on your game if you don't have the pilot with the driver bore in it. It can be pretty challenging. Okay. That's it.
She's done.
So SBI has recommended a seat that is a little bit smaller inside diameter.
Did we even talk about the press fit?
I think so. Yeah.
Okay.
Yep. It's a 2-inch part number seat, which the seat itself is actually 2-inch and 6/1000s, 5.5, 6/1000s. So you machine it for the 2-inch bore, counter bore, which we did, but the seat's bigger, so it presses in, press fit. I looked up for this head, the recommended seat, and you can see there's a little bit of a ledge there. So what we'll do is we'll go in and we'll blend that when we're done. So like a -2 seat would have probably been perfect. It would have it'd be a SB 2000-2, and then that inside bore would be a little bit smaller. And then that's how they go. They go smaller and smaller and smaller and smaller. So there would be a -2, 3, 4, 5. It'll just keep going down in that inside diameter. So ideally, if I had the head before I ordered the seats, I would have measured that throat diameter and then gotten a seat that is either the same size or maybe even tighter. Then we could have made it the same as that. This will mean nothing for this Jeep, right?
Yeah.
Like we'll blend this, we'll go in and we'll put a steep cut on there. We'll blend that. It'll be awesome.
So this is what Jay was talking about, the little ledge there, where if we would have picked a different seat, it would have been wider this way, and then it would have taken up that gap. But it's a little bit less on this edge, bigger over here. At least that's the way it feels. Could be wrong though. Anyway, you're gonna bowl cut that out a little bit.
Yeah, I think what we'll do is maybe take a real steep cutter and just kind of, or you could even just take a carbide burr and just roll that edge. It's on the intake side. Like I said, it's going to mean nothing for a 4-liter Jeep.
Yeah, especially on the intake because everything's coming in.
It's going that way.
Yeah.
Yeah.
You can just leave it if you want it. I wouldn't even care. It's up to you.
Yeah, we'll take a look. But first, let's get our pilot squared back up. So I think we explained earlier that we roughed this form cutter in with the old original seat to get our diameters really close. So the first thing we're going to do is we're going to cut this until we see our 45 show up, and then we're going to stop and we're going to put the new valve in it, and we'll show you where the contact is on the valve. We'll set our diameter and then we'll set our depth. The setup and all the work to do one seat cut is huge compared to just doing the whole head. So, but that's how machining goes. All right, so we mark our valve up. All right, so you can see it doesn't show up as good. I usually have a paint marker. So see the ring behind it, right above my finger between the two marks. You can see two lines, two faint lines and some faint. You can see where it's taken it off right there. And above that, we still have valve showing, machined valve area. So we can control where this seat contact occurs on this margin of the valve, not the margin, on the seat area of the valve by how we set that cutter. So that's the biggest I would want to set that cutter. We can't have the seat cut on the very outmost edge of the valve. You can't do that. And we could we could make the cutter smaller and we could put it way down so the contact's way down low, but that hurts the flow. So, not that we care about flow on this, but you know, that's all right. There's probably 75, 85 thousandths of the contact's probably 75 to 85 thousandths away from the edge of the valve. So we're fine with that. Okay, so diameter, I'm good with. Height is what we're going to dial in now. That pointer was set up to ride on the actual 45-degree part of the seat cut. And before, we had set this to 0. We were 0. Okay, right there's our sweet point. So we have 10, 20, 32 thousandths more of depth to go to match this seat to where the old one was. And that's how that gauge works. Real simple. So like if we were doing the whole head, we could take all them seats and we could get every single one of them the exact same height as each other, which would set them the exact same distance in the combustion chamber, and that would set them at all the exact same distance on the tips, assuming all your valves were the same length, which they should be especially if they're new. Now, does that mean a ton on a job like this? Right, like there's a 30 thousandths of an inch window of acceptable tip height for that valve job cut. All of this on this OEM stuff doesn't mean too much, but if you had CNC'd nice performance cylinder heads, and then you set every valve seat cut to the same height, you'll have consistent CCs from chamber to chamber. Everything will be I want to say exact. Nothing's exact, but nothing's perfect, but they would be, you know, as close as you could get them. This, on the other hand, being an as cast, you probably find a little bit of variation in the chamber size, even if all the seats were cut to the exact same depth. So what I'm getting at is it doesn't matter so much on the OEM stuff, but we do want to match it mostly so we get the tip height where we want it to be. Okay, so we'll cut it and we'll match them heights. We just determined that right now that seat is 32 thousandths of the seat cut needs to go down deeper 32 thousandths of an inch. And what I was telling you was we can't just set 32 thousandths, cut it and go. The reason for that is that, like Darren's saying, right now we have that guide compared to the machine, compared to the world, straight up, okay? And we have this gauge on it like this. But the deck of the head is like this. So this indicator is not parallel with the guide pilot. So if I just take and cut 32 deeper in this plane, that doesn't mean I'm going to read 32 thousandths in this plane. So if you wanted to get all crazy technical, you could trig all this out and you could figure it out. We're not going to do that. I'll go a little bit, we'll check it, we'll dial it right in, but it's important to note that you don't just cut to that height and then go.
And you were mentioning that on any engine that has a flat deck like
yeah,
diesel.
So if this was a diesel, our pilot would be square to the machine, but the deck would also be pilot because most diesels do not have any valve angle to it. So at that point, I would be able to set this gauge square and parallel with the pilot, and at that point, yes, you could. If we needed to go 32 deeper, we could just plow 32 deeper with the cutter and we'd be good to go. But that's not the case with a wedge head. This is basically wedge. So just important to know. So another thing to know, general information about this, is right now this seat is soft. that seat will, there's nickel, there's a lot of different, it's an alloy seat. That seat will work hardened. So right now it's soft, but as that gets temperature to it, it will harden. It'll change hardness just from the heat and running. It's in about 9.
So there we go. Jay cut in this edge right there, some just to relieve that, that little ledge. Seat's all cut in, looks good. Valve fits great. You can see we put a little bit of lapping compound on it just to kind of get an idea. Other than that, everything's good. All right, so we got the head back turned up. We cut in that undercut there, and then he's going to measure the tip height. We did the tooth out.
Yeah.
Under.
So this has a non-adjustable valve train. So the rock arms on this, they just get torqued down. There's no adjustment. All of these tip heights of the valve tip are machined at a certain distance so that preloads the lifter a proper amount. And so that tip height is, there's a spec on it. And in your particular case, it's 30 thousandths of an inch. It's 1 inch 775 to 1 inch 805. So your original tip height was 1 inch 792. And then when we were on the flip side, when we were cutting it, we didn't see this on camera, but my final cut was 2 thousandths of an inch deeper with this gauge. So if we come up here, we're 1 inch 794 and change, 4, somewhere in there. So just about that same 2 thousandths up on this side. So that goes to show you if you use that gauge and you have a height you want to achieve, you can easily do that with this gauge on the top side instead of trying to do this on the bottom side, which on this rollover fixture, this won't even work. But, so, point is, our tip height is still in tolerance. You'll still get your proper lifter preload. Everything is back to where it needed to be, because if we would have just tried cutting that seat, there's no way it would have cleaned up. Them 2 gouges were way too deep. There's no way. So, put a seat in it, recut it, there you go.
All right, so Jay and I started looking at, well, it started off that we had one of the valve stem seals had popped up onto the valve, and I didn't notice it. Jay noticed it. So then we started looking, and basically we pulled off a couple of valves. They're kind of beat up. Where's that one that's all gnarly? Well, they're all like that, all the intakes, right?
Most of them.
Yeah.
That stem's all, you can even feel it. It's all rough.
Yeah, it's all like chattered up, and
it should look similar to that.
Right. So
ground finish here. That's how it should look.
Yep.
But these are something went through there.
So we don't know what the deal is, but regardless, we
get pretty decent groove in there.
Yeah. So some of them are grooved up. Some of them have some marks. So I'm going to show you real quick. We're just going to touch up the valves. We're not going to cut. We're not going to do like a full valve job. But since we're already here, we're going to use the Quickway SV, and we're going to just touch up some valves. SVS, sorry. Mine's the SV. His is the SVS2. So real quick, it's got a button over here. You press it. It unloads the chuck. I need to sit you down. All right, so you release the button, it locks the valve into there, basically just like my valve grinding machine at home, the one that you might have seen. So the stone comes in, you crank it with this lever back and forth. This brings the spindle in and out. So we're going to turn this. The valve is turning, it's got lubrication on it. I had it backwards, I was turning the valve farther away. There you go, you can hear it start to chatter right there. Grab the lever, move it out a little bit. Crank this just a feather. And basically, that's all there is to it. Press the button, release the chuck. When you're all done, you got a nice shiny valve surface, valve face right there. And that's how you resurface valves. Well, this is no fun. It's 12 o'clock at night. I'm leaving Jay's. This is this is the calmest it's been, but I'm only doing 20 miles an hour. Anyway, got the head all done. It's sitting in the back. I don't know. This is pretty treacherous out here, so yeah. It is freezing outside. I just got done plowing a ton of snow. It's the next day. The head that we just finished is still in the other car, but originally my plan was that I didn't think we would have enough time over at Jay's. I figured I would just hold the camera over his shoulder, take a few quick little videos of what he was doing. Because he's so busy, we really don't always have time to shoot a big video like that over there. Things just worked out this time where Jay was able to give you guys a full lesson on how he does seats and stuff over at his shop with all of his tools. So that worked out great. So rather than dilute all of that great information by rolling it into a Jeep video, I'm just going to leave that as a standalone. So if anybody's searching for how that's done, they can see that rather than sitting through a whole video on a Jeep. And then we'll fix this as soon as the weather breaks a little bit, because it's going to be in the low negative teens for like 10 days. As far as the other things go, the rust repair caps that I reached out to Max Speeding Rods, and originally I was working on that 96. That was supposed to be the project. I told them I was working on it. I saw that they had these caps for a reasonable price. At the time that I bought them, it was like $315 or something like that for this whole kit, and we were supposed to work on that. Then this truck shows up on Marketplace. I bought that. It's a lot faster of a job, so I kind of feel bad that, you know, I reached out to them, and now this stuff will sit around for a little while, but it's just kind of how it goes. But the funny thing is, this truck already has some of those Max Speeding Rods rust repair parts on it. So let me show you those. So some of them, it doesn't have the centers or the fronts, which it really needed on this truck, but whatever. It's all just kind of cobbled together. You can see in the fronts here, once we go down here, you can see some of the patching up in there. Then it just continues to get worse. Down here, it's just a shallow patch at the bottom where those other ones come way up the sides a lot better. But there's a bunch of patches here and all along the bottom where these things always rust out. So you can see just how much rust was in this truck, this frame. And then we go back here, another gigantic patch, and it's the same on the other side. Body mounts is a whole different piece of steel. It's not included in the frame because it's not part of the frame. But right back here, you can see up in the back where that part ends, that's one of the rear caps that holds this control arm and the track bar and all of that. So you can see right here where it ends, right there, and goes down and encompasses this whole thing. So this kit would have been better to use on this truck than what they did, because they just kind of patched all of these different small sections in, where this has the entire thing that you need. It's got the centers, it's 1/8" steel, it's full welded on the inside. This is where your body mount would go right here, so it just slides over your existing frame, cut out the bottom or whatever, and you can see that the height of it takes up a lot more room. It's a lot stronger. Here's the rears. So you can see it's a complicated part here if you were to try to make it yourself, which I actually considered doing on the 96 before I saw that these were available. But it's full welded on the inside, everything again. So there's the rears, which is what you saw on the back of this truck. It's got the front control arm mount and the body mount up there. Right and left, it's all full welded on the inside too for the whole thing, just like this. Spot welded on the back, which I'm sure you could full weld if you really wanted to. But yeah, right and left rears, right and left fronts, and right and left centers. It's really not a bad gig because I don't even know if I could buy the steel to build those things from scratch for what they charge for the entire kit. So anyway, if you got a TJ with a rusty frame, maybe you want to save a couple of bucks, you can click on that link down in the video description, get yourself some, whatever. I don't make any money off of it. It's just, you know, what it is. Hopefully it helps somebody out. Other than that though, we'll get to this thing as soon as we can. I'm super appreciative of Jay for taking the time to show you guys and make a cool video showing the process of, you know, rebuilding the head and doing the seat and all that. He's a great guy. Hopefully we can convince him at one point to make a YouTube channel, but he's a busy dude. So anyway, it is what it is. Other than that though, hopefully you guys are enjoying your 2026. Thanks a lot for watching. Don't forget to like, comment, and subscribe, and I'll catch you on the next one.